Hey everyone, hope you're enjoying our previous classes. So last class we have learned about tokenization and stop word removal. So today we are going to learn about trimming, normalization, lemmatization, part of speech tagging. So stay connected and enjoy the session.
In this sentence, even if we remove the and each, still there is not much impact on the sentence. And the common stop words, if we remove that, still it will be okay to understand the whole sentence. So that is what we do in the common stop word removal. So again, consideration it is language specific, as I mentioned, different languages have different ways of dividing. But currently, most of these models, they follow the English type language. So like English is from left to right, writing. Some languages are right to left. Some are from top to bottom. Some are bottom to top. All languages have their own way of representation. Some words are so languages, there is no white space. There is no, uh, you can say stop words. And second, whatever you do after removing the stop words, you have to be understand that it has some meaning. It is useful for performing in the model. The second technique we call the stemming. So in natural language processes, when we retrieve the data, we always check which one is the root form of that data. Okay. So we remove all these suffix, prefix, and all this stuff, like as I mentioned, weekly. So in weekly word, we remove the ly. We try to identify what exact root of that word, and that is called stemming. Okay. Now, stemming is not always valid word for a individual language, or we can say that the meaning of a root language may be separate from the used language. So we also understand that and we normalize the words, okay, for our indexing purposes. So here is one of the example, you can say stemming mostly used for the normalization and reduction of the vocabulary. So by reducing words to their base root from the stemming helps treating different form of same word as an identical. For example, run, running, ran, all stem to run, simplifying the analysis of the text. Okay. So what we understand running means in a process in a progressive way, but the stem, the basic root of this word is run. So that means we normalize that. Instead of running, we understand it is trying to explain something related to run. Reduction of the vocabulary. By stemming, sometimes we reduce the size of the vocabulary. So again, as we discussed, it will increase the efficiency. It is improve the energy saving effectiveness for the algorithm. Now, how stemming work? Let's take one example. How we chop or remove the suffix prefix, that should be very useful. Example of stemming, consider the following examples of word. Running, runs, ran, runner, easily, fairly. So, so you can say it will be running, it will removing the ning and it only remain run. Runs, again run, removing s. Now running and runs very similar, but it may have different meaning in different words. Ran, again, runner, easily, fairly. So we remove all those stuff and trying to link that with common words. In this example, words like running, runs, and ran all reduced to run. Similarly, easily, fairly are came to easy and fairy, fairly, respectively. Okay. So what is the benefit of this stemming? Now, stemming is reduce, as I mentioned, reduce the length and reduce the unnecessary prefix and suffix, and we understand the root meaning of the word. So there are different techniques of the stemming. We'll not go in depth, but for the sake of your knowledge, I'm just water stemming. It is one of the oldest stemming which is used in 80s. Okay, it's applied a series of rules by stripping the common English suffix, and from there they can develop what exact meaning of that. Then after that, there is another person who is did research on the porter stemming and create another one, that is snowball stemming, an improve of over original porter stemming also created by the Martin Porter. Okay, then there is another stemming called steamer called that is called Lakensteer steamer, more aggressively than Porter steamer, developed at Lakensteer University. It apply a different set of rules and is known as its efficiency. Now, NASA also did some stemming and they found the best stuff is, Sanskrit has very good stemming process. They have some, we call the alankaras and dhatus or sabdarupa. And from there, they, that is the root. And from there, for each type of processes, each type of senses, sentiments, they created some rupas. So dhatu rupas, in like we say, um, runner runs, running, they already created, they fixed this team, the root, and from there they created all the sentences, balaka, balako, balaka. So that means even if any word will come very similar to that, it automatically linked to its root. So that's how they mentioned that the best language to use in computer world is Sanskrit. uh, the process, the research is still in progress. So I'm just example, one of the best of the language of Sanskrit is stemming. Other languages, they are random, they influenced by other languages. So that's how it is difficult to get the stem word very rarely. Like mostly in Bengali language, particularly, it is influenced by the Urdu's, by the Afghan Arabic languages. Okay. So in Bengali, they say Daria. Okay. Daria is just a word from Arabic, which is, they mean that to big rivers. Whereas in Odia, if you come, it will say Nadi. Okay. Now, if you go in depth of Bengali language, Daria actually not there in their uh, vocabulary. It come or influence that. Okay. So all these languages which are influenced by other languages, it is difficult to do this teaming. Whereas like the language Sanskrit, they created from this team and progress. It is always difficult to influence those kind of languages. So that's how it is one of the best examples for computer uses. There are limitation of this teaming as well. As I mentioned, sometimes we do overstemming. So the exact meaning of this stemming may reduce. Understemming also, that will reduce the meaning. And it is, as I mentioned, language dependent. So sometimes we are our algorithm using left to right or right to left, but the sentences are from top to bottom, like Japanese or Thai or Chinese. So everything is gone in toss. Okay, so it's language dependent. You need to understand how to stem the language. Now, stemming is applied in various language processes like information retrieval, text classification, document clustering, and sentiment analysis. Now, document clustering and sentiment analysis is one of the major part. So what it do, it will divide that all the sentence into classifications and then it will try to do. And all this type of stemming, as I mentioned, done by three major stemmers. Okay, Packer, Snowball, and Lackester stone. Then next process, we call that normalization process. So once we did the stemming, the next target is normalize. Normalize means we bring all the words to a common stem and we understand the meaning. So the normalization's objective is to clean the data, okay, and make the tokenized very useful, okay. Uh, and numerical normalization is also a process. Like if there is a person who is having some numbers in the sentence, what is your age? And he is replying point one, like first point, my age is 25 at 2000. Then my age in number two, he mentioned my age is um, like 45 in 2020. Now we need to normalize this stuff. We need to get the answer from there, and we remove all those stuff, understand the exact age of that person. Okay, and that can be done by understanding what is the points, like point one, point two don't mean anything. So remove those numeric stuff. The numbers which are linked to their age, the numbers which are linked to the year, those are having some meaning. Okay. So we do normalize, and once we do normalize, it will helpful to improve again the efficiency. Then we have a process called lemmatization and stop word removal. So stop word removal we already discussed. What are they? And lemmatization we'll discuss in next part. Then once we do all those stuff, we are doing the part of speech tagging. Now, part of speech tagging is like mostly we use that for your understanding the emotions. Okay, we call the labeling of the sentence or a labeling of each of the noun verbs and objective adverbs. And from there, we understand what exactly the sense of the sentence. So actually, there is a saying in the English that reading between the words, that what we exactly trying to get from the tag of speech. So it's mostly used for syntactic analysis, semantic analysis, and improve the NLP task. Now, syntactic, every language has their own syntax. So from the syntax, we understand the syntactic analysis. Okay, so what are the uh, grammatical role words? And then next is semantic analysis. What exactly uh, word meaning? What are the multiple meaning? So that we also do the graphs and understanding what means the probability of that word. So the syntactical analysis will reduce the sentence unnecessary stuff, and the semantic analysis is useful to understand the meaning of what exactly the prompt trying to push into the model. Improving the NLP task, enhancing the accuracy of the performance tasks such as name, title, recognition will also understand. Like if somebody will say, let's say somebody said, okay, it, there is an accident and the dog died and it was very painful for me as I am a um, I am a dog lover. Now in this sentence, the speech tagging, we understand there are some common points in the sentence. Okay. And but we can understand the semantic analysis as I am a dog lover. So we can see that this person has some attachment to the animals. That's how the sentiment is very high. So now the process, the language process, they understand that. They understand this person has high emotion values for the accident. So it has to auto-generate the text in a nature that yes, we understand your pain because you are a dog lover and very close to the animals. Definitely, it is very painful to see an accident on the road of these stray e-dogs. So that means the text generator understand and reply that in that way. Now, as we do the tagging, we can apply some rules to do the tagging. And these rules will apply on these tokens which are captured from the prompt. And the POC tags also useful to remove the stuff. Here, there is one example where it's saying that C likes to run fast. After the tokenization, it will come C likes to run fast. Now, in this, if we do the speech tagging, we can understand C is always a um, personal pronunciation. That means lady. Likes, it means singular presentation. That means individual label. Two, obviously, say infinitable. That means no quantification can be done. Run is a verb, and we understand it, it's linked to any action. And fast is adverb. And that means we understand it that there is something which is very significant. So from this, we can understand somebody is like to run faster, and we levelize all these meaning. And from there, we can get the exact input of this tagging. Okay. Now this speech tagging has different types. Like you can say there are uh, different techniques, okay, applied in this tagging. So mostly statistical tagging is very popularly used in many models. And as you did the machine learning task, you know that there are different models, hidden models behind this. And these models are like very much useful. So, but rule-based tagging is again useful for a context. Okay. And again, syntactical rules is applied there because every language has their own syntax rules. So that you can apply in the rule base. But statistical tagging useful for the models. And finally, in deep learning tagging, we utilize neural networks. So each time the neural network filter that and give you the exact meaning, which is mostly used in LLM. Then what are the issues with tagging? It's ambiguous. Like sometimes we tag some speech which is not labelized like that. Okay. So that is also a issue. It's issue with the human language processing also. When we talk, also we do labelize something which should not be there. Language specific nuisance are there, some meaning, some disturbed linguistic structures are there, which the speech tagging cannot handle. Some words which are not part of the same language family also come, and it is also difficult to labelize those words. So there are challenges still exist in the speech POS tagging or speech tagging, but the application is far, far more of speech tagging, mostly information retrieval, machine translation, entity recognition, text-to-speech system, all are actually based out of this speech tagging. Now, if you use a question, you pass a picture and ask what is exactly the picture is. So it uses multiple filters, okay, in deep neural network. Similarly, and it check all the characteristics and features of that image to understand what exactly its image meaning. Similarly, when we are giving any prompt in text format and it passed through multiple filters, it each time it will tag and understand what exactly the meaning is. So mostly we can summarize it. The part of speech tagging is a fundamental task in NLP that label words with their grammatical categories, enabling the deeper analysis and understanding of the textual data across various applications and domains. Lemmatization is a linguistic process used in natural language processes to reduce the words their base conical form, which is known as lemma. Unlike stemming, which chops off prefix, suffix without understanding the context, lemmatization considers the context and meaning of a word and derive its root form. As I mentioned last time, we are removing the syntax, we are analyzing the sentiment. Now here we also analyze the meaning, exact meaning of the root word. And the lemma represents the base dictionary from a word, which is typically a valid word in the language. Now, we have dictionaries, like in English, we have different dictionaries. So when we tokenize and remove everything and finally get a root word, to check whether it is valid or not. So what is the proposed? The objective is very clear: normalization, improve the text analysis and language understanding. Once we did all this normalization, improve the efficiency, improving the text analysis gives the like what exact information and what exactly the prompt is looking by doing the classification of the information. And then we do the sentiment analysis. And finally, we understand what exactly the meaning of that word from the lemma. And that's how the process progress. And through the tokenization, POS tagging, and lemmatization, we can exactly understand what the prompt mean and we process that. Here there is an example. Consider the word better in different contexts. Comparative adjustment, better. Verb, to better. I want to better tomorrow. I want to better in future. Noun, the better. The better your answer, the better your marks. So like each time the lemma is representing in a particular way that the meaning of the root will be different. Okay. So that's how the whole process is in progress and it's happening in that manner. Okay. The lemmatization and stemming is, it's understood very common, because stemming also we are going towards cutting everything, going to the root. Lemmatization also we are trying to understand the meaning of the word. But stemming, whatever the root we get, it may have meaning or it may not have any meaning. But lemmatization, it has to have a valid meaning in the dictionary. Otherwise, it will not consider as lemma or meaningful word. Okay. So what are the challenges in lemmatization? Like if somebody is used different language combinedly, it will create a ambiguity. Like in India, you will find that very commonly. Like in Odia, somebody will say Dangeria Lokota. So it means it's a dangerous person. But there is nothing like danger in Odia. And that is nothing like Ria Potteo, we call that in grammar. That is not in there in English. So somebody used both dangeria. So it means dangerous. Okay. So if you go to any border areas, like if you go to any border areas of two states, you find people who speak in a language that which is combined of the both languages. Okay, so like if you go to Chhattisgarh and Jharkhand, you will find people speak a Hindi which influenced by Odia, or you find that Odia is influenced bit of Hindi languages. So those stuff is there, and it creates ambiguity, and that is a problem for lemmatization. So if somebody use some language which is ambiguous in nature, the lemmatization process may fail because it always looking for a valid word. Like a saw, to saw, both are having different meaning. One is noun, a saw, saw that's a tool. To saw, it's a verb. Now it is confused. Okay. Computational cost. Lemmatization needs lot of computational cost. Why? Because it involves lot many libraries. It will check the word meaning each time when it get the basic form of lemma. And it needs huge amount of linguistic rules, dictionaries, and memory to process it. Application of lemmatization is mostly in NLP to understand the exact meaning. So information retrieval, get the named entity like orange, apple, all those stuff. Sentiment analysis, all this used through lemma. So thank you. This is the end of our tokenization process. Any questions on tokenization? So till now, we understand the basic stuff that there are a big area of AI, where there are another area called machine learning. In machine learning, we have different models. Then we proceed to deep learning, where we have multiple neural networks to get the answer. Then we progress in depth, okay? And we found a huge amount of data set which we can process. And we process that in two stages, prompting and data generation. And prompting also need to be processed through tokenization process to understand what is the exact meaning. And then we need to pass that to a model to generate the data.
So hope you enjoyed our today's session. If you like this video, then do like, share and subscribe our channel.